Hello students, coming to Java programming course, Unit 3, and you know that Unit 3 consists of two chapters. The first chapter is Arrays in Java, and we have created 5 videos for this chapter Arrays in Java, first chapter of Unit 3. Currently we are discussing about video 2 topics. Coming to these are the topics to be covered in this video about Arrays chapter of Unit 3. The first one, storage of array in computer memory and accessing elements of an array, operations on array elements, assigning array to another array, dynamic change of array size. Now coming to topic 1, storage of array in computer memory. And we know that we use this new operator to allocate memory for storing the array elements. And we already seen how to use this new operator for allocating memory for an object, for an array with specified size. And this new operator is for allocating memory for the array elements with specified size. Example, now we already seen about this type of declaration of an array and allocating memory using new operator. And here the compiler allocates 4 bytes, 4 memory spaces, each equal to 4 bytes, each equal to 4 bytes. Why? Because every element, every integer element can consume 4 bytes of memory in Java. Every integer element holds or required 4 bytes to store an integer element. That's why here this array is composed of 4 elements of type integer. So 4 memory locations, memory space is required for each 4 bytes for each memory location to hold one value of array, 4 elements, 4 bytes of each memory location. And storing that integer type values here, when an array is created as above, the elements of array are automatically initialized to 0 by the compiler. And we know that when we execute this statement, the 4 elements of this array and memory allocated for to hold 4 integer values, and that 4 memory locations are initialized with 0 automatically. But when you want to allocate or initialize this array with some elements, or that 4 elements, you can simply use this type of statement like this. And here we no need to use of new operator here. And you can directly define the type and declare the array like this, and assigning some values with curly braces and comma separated elements. And when you use this type of representation for initializing the array when declaring, when the time of declare, and automatically the compiler allocates these 4 values into num of 4 locations. The size is automatically calculated and all these values are initialized individually, and we see already this concept in the previous video. And coming to the storage of this array in computer memory specifically, and this is a logical view. When we assign or define an array with size 10, with array size 10, then 10 consecutive memory locations, 10 consecutive memory locations are reserved for this array for holding 10 integer values. For example, it may be a type of define this array as an integer type with size 10. Then automatically these 10 consecutive memory locations are reserved for this array to hold 10 integer elements. And how these elements of this array can be accessed by index of the array. Here this index, all these are array indexes. And we know that array index starts with 0. 0 to 9 is the index range of this array with size 10. And here every memory location, every element in the array has its own index to access that element. Right, got it? For example, when you come to the case of initializing and declaring the two-dimensional array, and here this also type of declaration, an array element, and we can use these two statements will work as same. And the declaration of num array, two-dimensional array, that's why we have used these two square brackets for two representing that the array declaring two-dimensional. A new keyword for allocating memory and followed by type of the integer and specifying size here. And without specifying size here, we can directly assign some initialized elements here. This 1, 2, 3 with the representation like curly braces and comma separated elements, and 1, 2, 3 is separate group and 4, 5, 6 as separate set. So here this indicate that the matrix contains 6 elements and the order of these elements is 3 by 2 by 3, 2 by 3. That it means 2 rows and 3 columns. Here 2 rows and 3 columns. And here it automatically indicates that this value is first dimension for this array is 2 and second dimension for this 2D dimensional array is 3. So it indicates the first value always indicates the row value. The first value always indicates the row value. And the second value always indicates the column value. And this element, 2D element array can be stored like this, a two-dimensional array like this, 1 and 2 and 3. And this one is 4 and this one is 5 and this one is 6. So here the matrix order is 2 by 3, 2 rows and 3 columns. Got it? And we can write the same representation like this also without using new operator here. So int two-dimensional array identifier array name, and we assign directly the elements to this two-dimensional array. Next topic is accessing elements of an array. How to access elements of an array? And we know that index value and every memory, every array element has its own index. As like the logical view point of view, every memory location has address to access. The same way, we consider that address of memory as an index of array to access the elements of the array. Here, the individual member of an array may be accessed by index, and the index value represents the place of element in the array, where that element, what is the element position in that array, and that index represents the index of an array automatically starts from 0. And here, coming to this position, consider this as a balanced array, and where it has some elements like first element, second element, and third element. And the indexes are like starting from 0 and 1 and 2. Here it is the example for accessing array item. Array item nothing but one of the value of this array. So indicating or representing that array name square brackets and the index value to access that position element of the array. So here this one indicates that is the first index, nothing but second position element in the array. Second position element in the array, because array index starts from 0. So the output of this one is 200. So by index only we can allow to access the elements of an array. Got it? And coming to the next one, operations on array elements. Generally, an array element is a variable of type declared with the array. And when we declare an array with specified type, the values or elements can hold by that array is of same type. When we declare an array type as integer, and the elements in that array all are integers. So all the operations that are admissible for that type of a variable can be applied to the individual array element. That it is when the type of an array is an integer, and generally we know the basic type integer, some set of operations are admissible for that type, and all that operations are allowed to apply the array elements what the array hold, that integer values. We can also apply that operations on that integer array, nothing but the elements stored in that integer type array. Yes, it is allowed like that. And the thing it is saying, similar to primitive type of types or objects of classes, the array may also be declared as a parameter of the method. And till now, we've seen some basic data type or primitive data types we can send and use as a parameters for methods. Either it may be a member function or a method in a program. And we already seen that objects of the classes also use as a parameter of a method. And in the same way, here, these arrays also we can use and as declare as a parameter of a method. That array also declared as a parameter of a method. That is the example here. First of all, we know that method identifier, that is method name, the function name, and the function type of the function, and the access specifier. In Java, it is very important that when we are defining a member of a class, and that should be mentioned the access modifier of that member of a class, and this it is allowed. So generally this access modifier, and we know the public, private, protected like, and this is method access modifier and type of the method name or method identifier, and parameter list here parameter list. In parameter list, one of the parameter we can use array as a parameter and specifying the type of array with empty square brackets. No need to specify the size here. It automatically takes when the compiler encounters this statement, it automatically calculates the size that you are passing based on the name of the array, right? And here other parameter specifying with some types, and we can use an array as a one of the parameter to a method. The best example we know from the previous videos or previous syllabus or previous topics experience, and main is a method in main class, and it has a parameter like args array. So here it is the thing clearly we gone through this one. We can use this array as a parameter to a method. This is the best example we know that. So this main method type is a void, return type is void, and also a static method, and the static is a keyword, and this method access specifier or access modifier is a public, and main is the method name, and for this method there is one argument or a parameter is that args array. It's an array, and what type of array it is? String class object, and we can take this as an string class object or a string array, and this array can hold the objects of the string literals or string values. Got it? Understood? And what are the operations are generally possible on the arrays is, and we will see this one in the next video clearly. And for example, when we have sorting and searching and operations, there you already gone through the data structure concepts in the previous semester, and we know that sorting of elements from set of given elements, that are elements sort, how to sort those elements. We hold all those elements stored into an array type, right? In the same way, searching of a particular element in a set of elements. And for representing that set of a group of elements, we use a data structure called array. And among the array are different elements of the array, and we are going to apply some searching methods for searching searching for a desired element in the array or set of group of elements. We will see this one clearly in the next video. And coming to the next topic, assigning array to another array. Yes, it is generally possible. One array elements can be assigned to another array. And there is a small difference here. It is compared with the previous languages like C and C++. In Java, this operation is somewhat different. Unlike in C and C languages, in Java, an array may be assigned as a whole to another array of same type. Yes, it is allowed like in Java, it is allowed. We can assign one array to another array, but the condition is both arrays should be of same type. Next one, in this process, the second array identifier in fact becomes the reference to the assigned array. This need to be understood clearly. When we are assigning, when we are created one array or declared one array, and when we assign in this process, assigning one array to another array, that second array, whatever it is, and it becomes a reference to the assigned array. That it means I declared an array A, and I have another array type this one, and assigned this array A to this B. But just for understanding, I'm saying I'm assigned just an array A to array B. That it means that B is not a new array created, it's just a reference to the existing array A. That is a point to be clear, need to be understand here in this Java, that is the difference. That second array is not a new array. Yes, it is. That is not a new array, and instead only a second reference to a created array of first. Okay, we'll see this one in this example also. This one is an original array and copy of data given to another array. So here the copy is said to be nothing but this is the original array content, but we just created a reference to this created array, second reference. And to better understand this one, this is the best example program. So see here in this test class, in void main function, I have created one array. Create an array. Here, this I have declared one array and initialized with 3 values. The size of this array is 3. And now I have created one new array with length of a array. Whatever the a size I declared and created, that size of an array is passed as to declare a B array with new operator. Here by executing these two statements, it doesn't mean of the here two arrays are created. It not mean that. Only one array is created, that is A, and B will act as a reference to that created array A, and not B separately memory allocated for B. Only once memory allocated for A, and B is a reference to that memory. Okay, here when I am assigning this address A, array A to B, here does copy elements A and B only makes B refer to the same location. It doesn't copy elements of A to B. This is very important and need to be understand and remember to remember in a time when we discuss in the further topics. It mean of doesn't copy elements of A to B, only makes B refer to the same location of A. This is the meaning of this one here. This is this technique. And when we change the elements of array to B reference, it automatically reflect in the A reference memory also, because only one memory is created for array, and A is first reference to that memory location. B is the second memory reference. It automatically, whenever you apply operation or a change of value or operation on the elements of an array, either it may be through reference A or reference B, and both the way it reflects the memory. The same type of operation reflects on the elements of the array. And for example, to understand that one, I'm going to increment the B of zero element. B of zero element. B is a second reference, and I'm the first element of the array, first index element array. I'm just incrementing. First index of an array element is 1. When I'm incrementing, it becomes 2. 283, right? 283. So I'm going to display the elements of A through A reference. So I'm displaying the contents of array A like that, and for loop and displaying the value. So this statement simply displays the contents of A like this, 283, 283. Here one automatically incremented because we incremented this one. Observe this one. We applied this increment operator through reference B, not A. But even the memory location is created for only one array and these AP are acting as the references, then that operation automatically reflects in the memory. And when trying to the same B elements with this statement, then it automatically displays the contents of B like this, 283. Both are same. Why? Because we assigned and we created two references, and assigning here is nothing but a copying reference of or assigning another reference to the memory array created for the first. Understood? Coming to the next one, dynamic change of array size as it is possible in Java. The number of elements, nothing but a size of an array, may change during the execution of program as it is possible, and this the process is called dynamic change of array size. This feature is unlike C and C++, wherein in C and C++, once the array is declared with a fixed size, the number of elements cannot be changed. The number of elements cannot be changed. It is static allocation in C and C++ about this array concept of this size with respect to size of an array. But it is not the case in Java. In Java here, however, you may change the number of elements by dynamically. Dynamically at runtime, at any time of your program, you can change the size of the array that the existing or allocating memory for the array. And we can allow to change the existing array size dynamically in any time of your program, at anywhere of your program, with the specifying array name. I will show you the example of this one. Right? We can change the number of elements of an array dynamically. In this process, this is very important. Have a concentration here. The old array is destroyed along with the values of elements. The array is completely destroyed with the whatever the elements is stored in that memory completely deallocated and destroyed. And new size array declared with the same name, and all are initialized as 0 with 0, as it is normal process automatically by the compiler when we create a new memory for an element. So coming to understand better this one, let us have some example program here. In declaring num array and using this new operator, I am allocating the memory size for this is 5. So this is very clear. So now I have created that declared an array num with size 5. It allows to hold 5 integer values, right? And when at any time of your program, you can change the size of this array num by using this statement, by representing this statement. Num array name is equal to new operator followed by type of the array. And in the square brackets, you can specify the size dynamically here, 10. When the compiler executes this statement, the previous array is completely destroyed with along with the values, and new memory allocation allocated for this with this array name and with size 10, and all locations of this 10 of this array initialized with zeros, right? And coming to this example for better understanding. So initially I have created an array A with size 5, this is array index range 0 to 5. 5 elements already stored, and these are the memory references, indexes given of an array A like this, 5802 like this, 4 bytes, right? At the time of the program size, when we declare the same array name with A of size 10, size 10, that the previous slide example, that here it is size 10, that it means initially like this, and now I changed the size with 10. When execute this statement, the compiler automatically creates, and this array is completely destroyed with all the elements, and new array is created with same name A, and with the separate indexes, and all the values are initialized with 0. This is the concept called dynamic change of array size. Dynamic change of array size. Got it? And for better understanding, for example program also given. So dynamic array size inside main function. I just first declared one array A, and without new operator, I can allow to initialize 5 values to this array. So it is clearly indicating that these elements are initialized to this array A. And I'm simply displaying on the screen. I'm displaying using this system.out.println statement and using for each loop. This is a version of the for loop in Java. Here it is simply displaying all the elements in the array A. So this is the output of this program. Like this. It displays 1, 2, 3, 4, 5. Whenever I am additionally adding one statement to this program. See here, same program, main function, same array, but before displaying this one, I'm just simply updating the size of this array by executing the statement like this. Okay. See here, when this statement executed, the previous allocation memory for the A is completely destroyed. New memory is created with 10 locations of memory for holding 10 values, and all these locations of this array are initialized with 0. Then when we are trying to display the elements of an array by using for loop and printf statement, the same way, it simply displays the output like this. This is the output of this program. All 10 locations are initialized with zeros, and all that 1, 2, 3, 4, 5 elements of previous allocation completely destroyed. Got it? And these are the references, and thank you.